structures, Rome's Pantheon and a modern parking garage, stand as a stark contrast. One endures for millennia, the other crumbles in decades. Why did ancient builders create such lasting monuments, while our modern structures often fail so quickly? In 2023, MIT uncovered the self-healing secret of Roman concrete, a lost technology that hints at a broader story of forgotten genius. Medieval builders mastered materials and nature, creating beautiful, sustainable and resilient structures. Today, we'll explore 7 extraordinary medieval construction methods, each a testament to ingenuity that could reshape our future. Let's begin. Roman concrete's secret wasn't just volcanic ash, but a process called hot mixing, adding quicklime to the mix, creating lime clasts. These white chunks, once thought to be floors, are actually pockets of reactive calcium. When cracks form, water activates the lime, triggering a chemical reaction that fills and heals the fissure. This self-healing ability is why Roman aqueducts and harbours have survived for centuries. Modern concrete, by contrast, is rigid and brittle. Cracks lead to corrosion and costly repairs. The Romans embraced adaptability, engineering a material that could regenerate. Their concrete was a living system, designed for resilience. By valuing longevity over speed, they created structures that endure. Our modern approach, focused on initial strength, misses this crucial lesson. The genius of Roman concrete lies in its ability to heal, not just to withstand. It's a philosophy we'd do well to remember. Ancient European buildings owe their longevity to lime mortar, not just stone. Unlike hard, impermeable cement, lime mortar is soft and flexible, allowing buildings to move and settle without cracking. It absorbs stress, sacrificing itself to protect valuable masonry. Lime mortar breathes, letting moisture escape and preventing destructive freeze-thaw cycles. Cement traps water, leading to spalling and decay. Lime mortar is also more sustainable, produced at lower temperatures and reabsorbing CO2 over its lifetime. It acts as a slow-motion carbon sink, quietly benefiting the environment. We replaced it with cement for speed, but lost durability and breathability. The result, modern walls that suffocate and self-destruct. Lime mortar's gentle, adaptive nature is a lesson in building for the long term. Sometimes slower is better. Medieval timber-framed buildings relied on mortise and tenon joints, locked with wooden pegs through a technique called draw boring. The offset holes create tension, pulling joints tight and keeping them secure for centuries. No metal required. These joints flex with the wood, adapting to humidity and movement, unlike rigid metal fasteners that corrode and fail. Builders used green oak, knowing it would shrink and tighten the joints over time. This deep understanding of wood created living, flexible structures that endure. Gothic cathedrals revolutionized architecture with the flying buttress. Instead of thick, fortress-like walls, builders used external arches to redirect the roof's outward thrust to distant piers. This freed the walls to become thin, delicate screens filled with stained glass, flooding interiors with light. The flying buttress was a practical, hands-on innovation. Master masons learned by building, observing, and sometimes failing. Each cathedral pushed the limits of stone, blending structural necessity with artistic vision. The result, soaring spaces that feel weightless yet stand for centuries. It's a perfect marriage of physics and beauty. Cob construction, Walls made from clay sand, straw and water creates homes of remarkable comfort and longevity. Thick cob walls act as thermal batteries, absorbing heat by day and releasing it at night, reducing the need for artificial heating or cooling. Straw adds strength and insulation, while clay regulates humidity for a healthy indoor climate. Built slowly, layer by layer, cob walls are sculptural and organic, blending structure and art. Unlike modern synthetic walls, cob is simple, fireproof, pest-resistant, and fully recyclable. At the end of its life, a cob house returns to the earth. This ancient method offers a sustainable, resilient alternative to today's disposable construction. Sometimes, the simplest materials are the most enduring. For millennia, thatch, reed and straw was the roofing material of choice. A well-made thatch roof insulates better than modern shingles, keeping homes cool in summer and warm in winter. Its steep pitch and dense layers shed water efficiently, while allowing the roof to breathe and prevent condensation. Properly maintained, thatch can last decades, and when replaced, it composts back into the soil. Fire risk led to its decline, but with modern safety measures, thatch remains a sustainable option. We traded its natural benefits for convenience, losing a craft that sheltered generations. Thatch proves that tradition and sustainability can go hand in hand. Before air conditioning, architects like those of Sicily's Ziza Palace mastered passive cooling. A central hall, fountain and wind tower create a natural airflow. Hot air rises and escapes, drawing in cool air over water channels. Evaporation cools the air, while thick stone walls and small windows regulate temperature and sunlight. The palace becomes a climate machine powered by sun and wind, not electricity. Modern AC fights nature, consuming energy and worsening the problem. Ancient builders worked with the environment, not against it. Their elegant solutions offer lessons for sustainable comfort today. These 7 technologies reveal a mindset focused on resilience, repair, and harmony with nature. Ancient builders thought in centuries, creating legacies measured by endurance, not speed or profit. We've traded longevity for convenience, building disposable structures and environmental debt. But the wisdom of the past isn't lost. It's waiting to be rediscovered. By learning from these methods, we can build a more sustainable future. Share this video if you value real craftsmanship, and subscribe for more lost wisdom. Until next time, keep building.